Hi, my name is Sophia Smовж. I'm from Kyiv, Ukraine, and my project is called Synthesis of Optically Active Dimethyphosphinoyl Analogues of Fotemustine. So let's start. Organophosphorus compounds have been used as drugs for decades, and many of them have achieved commercial success. Among them, there is an anti-cancer drug's active substance called fotemustine, a cytotoxic alkylating and carbamylating agent. Due to its high lipophilicity, fotemustine overcomes the blood-brain barrier better than other nitrosoureas and spreads faster in the body tissues. It has shown excellent anti-tumor activity, including in the treatment of brain tumors. At the same time, the main problem in search for new drugs among organophosphorus compounds is the low water solubility of their esters. Unfortunately, this also applies to fotemustine, which is administered as a solution in glucose, which limits its use in people that also have diabetes. Recently, it has been shown that the presence of dimethyphosphinoxide group in the molecule determines its water solubility without reducing the permeability through the cell membrane. Therefore, replacing the diethoxyphosphoryl group of fotemustine with the dimethyphosphinoxide group should significantly increase the water solubility of the molecule. In addition, fotemustine is a racemate, which can also be attributed to the disadvantages of the drug, because it's well known that the optical antipodes often have different biological effects. That's why the main goal of the research was to obtain dimethyphosphinoyl analogues of fotemustine in enantiomerically pure form. Fotemustine molecule consists of three structural fragments: nitrosourea, chloroethyl, and phospholamine, which is responsible for the permeability of the active substance through the membrane of cancer cells. In an aqueous environment, fotemustine decomposes into two reactive compounds: 2-chloroethyl diazohydroxide and the imminol tautomer of the starting substance. The first compound plays a key role in realizing the cytotoxic mechanism of action of fotemustine. It alkylates the DNA of cancer cells with the formation of guanine-cytosine crosslinks. Their large number leads to the disruption of the processes of replication, DNA repair, and gene expression, and ultimately to the apoptosis of cancer cells. The fotemustine synthesis scheme includes three stages, the first of which is the Kabachnik-Fields reaction, a three-component condensation of amine, acetaldehyde, and diethyl phosphate, which leads to the formation of alpha-aminophosphonate. Its carbamylation with isocyanate followed by nitrization allows obtaining fotemustine. However, this approach is unacceptable for the synthesis of optically active compounds and leads to the formation of only the racemic form due to the absence of a source of chirality. Therefore, to obtain non-racemic derivatives, asymmetric synthesis was used based on the addition of dimethylphosphinoxide to optically active imines, which contain a stereodirecting third butylsulfonyl group next to the nitrogen atom of the azomethane bond. For this purpose, the synthesis of starting imines was carried out using the synthetic procedure described in the literature, which involves the condensation of acetaldehyde with L-manamide in R or S configuration in dichloromethane in the presence of magnesium sulfate. Subsequently, the obtained imines were introduced into the addition reaction with dimethylphosphinoxide. It was established that the addition of dimethylphosphinoxide to the C-N double bond of imines occurs under mild conditions at a temperature of -15 degrees Celsius in tetrahydrofuran in the presence of titanium tetraisopropoxide and is realized with the almost quantitative conversion. This leads to the formation of alpha-aminophosphinoxides isolated in an individual state with the preparative yields. It's worth noting that the formation of the second diastereomer was not detected when studying the reaction mixture by the INOVA method on a phosphorus nuclei. The reaction is stereoselective. The reaction mechanism most likely involves a nucleophilic attack by a lone pair of electrons of a phosphorus atom in a trivalent form on an electrophilic carbon atom of the C-N bond. When using R-amine as a substrate, the newly created stereocenter also has R configuration. Such a stereochemical result can be explained by the realization of the reaction mechanism through the rephase attack in the open transition state. Titanium tetraisopropoxide in this reaction obviously performs a double role, on the one hand activating the double bond of aldimine, and on the other hand shifting the balance of tautomerism of the phosphorus reagent toward the trivalent form and thus promoting the course of the reaction. The absolute configuration was determined by compression with analogues that were synthesized according to the same scheme and investigated by X-ray structural analysis. The next step in the synthesis of fotemustine analogues was the removal of the sulfonyl group from amides using a solution of hydrogen chloride in dioxane. To confirm enantiomeric purity and rule out possible racemization, the obtained optically active aminophosphinoxides were analyzed by NMR spectroscopy on fluorine nuclei in the presence of Morcher's acid in the R and S configuration. The enantiomeric excess reached 98%. Then both enantiomers were subjected to further transformations in accordance with the fotemustine synthesis scheme. As a result, optically active nitrosoureas were isolated in an individual state with preparative yields, and they were found to be readily soluble in water. The obtained compounds have a potential to be used as drugs and will be transferred for the following preclinical and clinical studies. The utility patent is being prepared based on the results of this work. Also, this project was awarded by the American Chemical Society at the International Science and Engineering Fair this year. Thank you for your attention.